Hello and welcome, everyone. I am Marinos Stylianou, and I lead the AEC strategy at Altair. Before we start, I would like to thank our keynote speakers for their very informative and inspiring talks. My goal for the next 20 minutes or so is to give you an overview of our AEC solutions with an emphasis on what's new. There is a lot to cover, so if you see or hear anything that piques your curiosity and you want to learn more, I encourage you to contact our technical support team or your account manager. They would be happy to arrange a meeting with you. We have 4 categories of solutions for the AEC industry that we will cover together. Software for code-based and performance optimal analysis and design, machine learning, AI, and high-performance computing solutions, and our unique units licensing. I believe that these 4 categories of solutions together set Altair apart. I will actually start with the last category because licensing impacts all of you, and because we also have evidence that many of our clients in AEC are not aware of what is available to them through this unique licensing system. So how does it work? Well, first, clients acquire a pool of shareable units, which give all users access to multiple products from any location within your geographic region. Units are drawn from the pool when you access a product and return to the pool when you exit the software. Now, these features combined result in a more efficient use of your software assets and present the potential for a significant reduction in spending. Please bear in mind that all our software is available through the units licensing system, and that all our customers are using Altair units to access their software. And for instance, for AEC, we have 2 unit suites specifically created for you. The first one is the Structural Engineer Suite, which includes these 14 products. If you're currently using any one of these, then there is a good chance that you have access to all of them. For example, this week, you could have all your engineers use S-Frame and S-Steel to complete an urgent steel design project. And then next week, you could have some of your engineers use SimSolid to model and analyze a complex connection. And at the same time, some of your engineers performing code checks on a concrete multi-story building. The units are flexible this way, and they allow our clients to meet their constantly changing needs. The second suite is the Advanced Structural Engineering, or ASE, which includes these 21 products. 6 of them are upgrades from the SE counterparts, but plus 7 new advanced simulation solutions. If there is one thing that I would like you to take away from this licensing discussion, is that today you have access to anything from 14 to 21 products, and I encourage you to communicate that to the rest of your organization so that you can begin to use these assets more effectively. Now, unlike the SC suite, this suite has many solutions that would apply to engineering groups outside structures, such as the mechanical, electrical piping, and architecture. Let's look at our solutions portfolio for the AEC industry. As we saw a few slides ago, we have 2 main categories of simulation tools. code-based analysis and compliance checks, and performance optimal analysis and design. We will start by looking at solutions for code-based design first. No big surprise here. These are software that operate within the bounds defined by national design codes, and they are designed to address most of the everyday analysis, code checks, and reporting needs of structural engineers. Our code-based solutions are integrated among themselves, but they also operate as standalone, which makes them ideal when brought into an engineering design group for the first time, because they can be easily adapted to existing best practices and workflows that rely on third-party solutions. S-Frame is the structural analysis program. It uses 3D geometry, section, material properties, load cases, load combinations, and it then computes forces, displacements, stresses, frequencies, mode shapes, etc. As timber, as the name implies, it focuses on timber structures. One can model a structure, run analysis, and perform code checks in one environment optimized for timber structures. As timber uses the S-Frame finite element analysis solver. As concrete performs reinforced concrete section design and code checks of beams, columns, and walls. It comes as standalone, but also fully integrated within S-Frame. It is also the reinforced concrete design engine behind Multi-Story Designer, which of course interfaces with third-party software like ETABS and soon STAAD and Midas to perform auto design and code checks of complete concrete buildings. S-Line performs code checks for multi-span continuous beams. S-Calc is our section property calculator. It computes section properties, including things like warping constants and shear area of multi-material sections. S-Steel and S-Pad, our steel design software. S-Steel is fully integrated in S-Frame, and S-Pad is standalone. Otherwise, they both support the same national design codes and perform the same code checks and generate the same engineering design reports. With S-Foundation, one can model a foundation, run analysis, and perform code checks for a variety of foundation types in an environment optimized for foundation design. The support loads can come from third-party software such as ETABS and STAAD, and soon Midas. S-Foundation also uses the S-Frame FEA solver. Now, these solutions exchange model and result data with CAD, BIM software, AutoCAD, Revit, and Tekla, office productivity tools such as Excel, Access, and Word, as well as third-party structural analysis software, including ETABS and STAAD, and soon Midas. Python is the scripting language for customizing and automating best practices in S-Timber, S-Foundation, and S-Calc using an API. Now, if you remember, all these products were included in both the SE and the AEC unit suites. So chances are that you already have access to all of them. Our code-based solutions have broad applications in structures. These are images from some of the applications that our clients shared with us: modeling and analysis design of domes and fabric structures, hotels and convention centers, short to medium span bridges, auditoriums, tall buildings, and foundations. Coincidentally, the foundation shown here is courtesy of Skidmore, Owings and Merrill. It is a model from the Burj Khalifa in Dubai, which became the tallest building in the world in 2007. S-Frame and S-Concrete were used in the analysis and design of that building. On the industrial side, modeling and analysis and code checking of plants, roof structures, refineries, complex truss structures, cranes and trestles, tanks and silos, guy towers, suspended pipelines, and many more. And in the area of timber structures, as timber supports parametric design, hybrid timber steel structures, and code check and design of standard rivet and bolt connections. You can learn a lot more about S Timber from Moin's workshop in the timber track later today. For foundations, S Foundation supports isolated footings, mat foundations, combined continuous wall footings, and of course, deep foundations. And two examples of our section probability calculator, SCalc, which can handle composite and multi-material sections. There is no section too complicated for SCalc. So what's new with code-based solutions? We are excited to announce support for two new regions, India and South Korea. Steel and concrete design codes for India have already been released. Steel design code for South Korea has already been released, with concrete scheduled for later this summer. Lot of news for the European Union, with support for both steel and concrete annexes for Germany, Spain, and France. We are working on updating to the latest Canadian concrete design code, CSA 823.3.24, and we are getting ready to update to the latest American concrete design code, ACI 31825, which, as we understand, should be available anytime now. Along with the expansion of design code coverage, we've already added steel section databases, 4 for India and 1 for South Korea. S-Frame's multi-story builder with its multi-view interface is relatively new. It's fast and easy modeling of multi-story structures with enhanced floor and elevation definition and editing tools. Side-by-side display of model and separate views for geometry setup, loading, and post-processing. It features advanced grid system definition for easy modeling of complex shaped structures. Multi-Story Designer now performs code checks and automated design of all reinforced concrete beams, walls, and columns in a structural model from ETABS and S-Frame. What used to take weeks to complete can now be performed in a few hours. It uses S-Concrete's trusted design engine with a simple design group management. It generates transparent engineering design reports, just like S-Concrete does. There will be a lot more information about Multi-Story Designer in Tyan's workshop in the concrete track later today. The demand forces, of course, come from ETABS, but now also from S-Frame, and soon from STAAD and Midas. Multi-Story Designer supports the Canadian, American, European, and now including the UK, and soon will include the Indian and South Korean design codes. Load generators for wind and seismic loading is something many of you have been asking for a long time. With the development of the multi-story builder, this became possible. So we implemented both, for the seismic load generator, it follows the NBCC and the AEC 7 and Eurocode specifications. But soon we will add support for India, South Korea, and the European Union codes. For open structures, we support the American Petroleum Institute specifications. Earlier this year, we released support for the latest GFRP code, the ACI 440 11-22, a sister code to the ACI 31819. Concrete design software can help engineers new to the use of GFRP rebars by presenting alternative designs using GFRP and steel rebars for easy comparison. You can learn a lot more about GFRP rebars later today from MST Bar's CEO Borna Hajimiraga's presentation in the concrete track. Moving on to our performance optimal solutions category. This category of solutions is for solving engineering problems that are beyond the scope of national design codes and for making it easier to evaluate more conceptual design options in search of optimal ones. Let's start with Inspire and Design Explorer for evaluating design alternatives, especially during the early phases of design. Hypermesh and OptiStruct, two of our flagship simulation software for detailed high-fidelity modeling, analysis, and optimization. EDEM, simulation of bulk and granular materials and their impact on conveyor belts, transfer chutes, mills, etc. CFD with AccuSolve and UFX for wind loads on tall buildings and pedestrian comfort studies, as well as thermal analysis for HVAC applications. Impact and blast simulations with Radios, our explicit dynamic solver. The game-changing meshless technology of SimSolid, which is proving to be an extremely effective and productive tool for the simulation of complex 3D geometries and assemblies, which are often found in connections and facades for AEC. And last but not least, our math-based solution of Compose, a MATLAB-compatible software. So if we look back, and if you remember, most, if not all of these products were included in the Advanced Structural Engineer suite of units, which basically means that if you have AEC, you already have access to all of them. And you and your colleagues could be using them to perform advanced investigations similar to the ones we will discuss next. So what's new with performance optimal solutions? Well, let's start. We continue to update and improve our links to third-party BIM software and structural analysis software, as mentioned earlier, and soon we will add Midas. But in addition to that, we are making it easier for our users to get to performance optimal solutions from our code-based analysis software by exporting to the .fem file format. By the way, once the model is in Hypermesh, it can then be converted to any third-party finite element analysis software. And now, Hypermesh also imports 3D geometry from IFC files, typically exported from popular BIM software, as shown here with an example from Revit. One can import the structural, the mechanical, electrical, piping, or the architectural models from an IFC file. If you have a need for stress analysis of complex 3D geometries, even occasionally, SimSolid is the ideal solution to go from 3D CAD to analysis with no need for CAD cleanup or simplification and no need for meshing. Yields accurate and much faster results than current tools. You get results in seconds to minutes instead of hours. You can perform linear and non-linear static, dynamic, and thermal analysis. It performs automatic bolts and nuts recognition and automatic contact and weld creation. I recommend attending Matthew's workshop in the steel track later today to see SimSolid in action. Modeling, stress analysis, and optimization of complex connections and assemblies, as I said a couple of times already, is ideal for SimSolid's meshless technology, but it is also ideal for Hypermesh and OptiStruct for optimization. And we have seen an example of that in Justin's keynote speech on steel castings of complex connections earlier today. We've added nonlinear soil concrete material model to Hypermesh and OptiStruct to conduct studies involving tunnels, soil slope stability, dams, active and passive soil pressure, lateral load capacity of piles, and load capacity of groups of piles. Moving on to Eden, this is a discrete element modeling solution for simulating bulk material handling in mining and agricultural industries. Eden helps engineers gain a better understanding of the behavior of bulk materials in motion and their interaction with processing equipment such as conveyors, transfer chutes, mills, silos, etc. This chute and conveyor belt were redesigned with the help of Eden. They were installed in 2020 as still in use today, saving the operator around $1 million so far through increased throughput and reduced conveyor belt and chute wear, material spillages, and blockages. As you probably guessed already, Eden can be used to extract the dynamic loads on supporting structures, as shown here, where the dynamic loads from the filling process of silos with grain can be transferred to OptiStruct, SimSolid, and or S-Frame for structural analysis and design. And I would like to end this section on bulk material handling simulations with a customer testimonial to Eden's use at Hatch. We plan to hold a 2-hour workshop on Eden applications in AEC around June, so please be on the lookout for email announcements. The automotive industry has been using simulation technology for years to improve passenger safety, and Altair has been a leading provider of this technology for decades. For the AEC industry, we can assume that the vehicle is well designed and passengers safely strapped in their seats, and we turn our attention to the damage the vehicle will cause on the infrastructure it's crashing into. This reinforced concrete column, for instance. Modeling is done in Hypermesh, and the solution performed by explicit solvers such as Radius, which gives an estimate of the damage with these red bands. Topology optimization. This also originated in the automotive and aerospace industries, primarily for weight reduction, but it does have practical applications in AEC as well. We have actually seen an example in Justin's keynote speech on steel casting earlier today. Now, in this very simple AEC example of a model bridge, we see how this technology can be used to find an optimized use of material along the load paths. From that, one can then rationalize a stick model within S-Frame and then follow a typical steel design process within S-Frame and S-Steel. Here is a more comprehensive example of global topology optimization for a tall building where, again, we get the load paths that can then be used early in the design process to define a conceptual load-bearing structure. We have numerous solutions for machine learning and AI, primarily for the banking, securities, financial services, insurance industries. The one relevant to engineers is called Physics AI. Physics AI is domain neutral and is used today by engineers in various industries and disciplines. So what we've done is we've embedded machine learning and AI capabilities in our Hypermesh platform. There, users can provide models for machine learning training purposes and then deploy AI augmented engineering methods that recognize and classify patterns and shapes and quickly compute performance predictions of early conceptual designs. I invite you to work with us to demystify AI for AEC in your area of interest. Using physics AI with our help, with your data, in a secure, transparent, and industrial strength environment. We are adding automation to Hypermesh to easily create wind tunnel replicas to run multiple CFD analysis for several wind directions and to then post-process the transient pressures to compute facade forces, floor forces and moments, base shears, overturning moments, etc. This technology will also feature automated workflows for CFD urban wind analysis with statistical post-processing to evaluate pedestrian comfort metrics. The capabilities for wind loads and pedestrian comfort are already available in our advanced solutions. These two projects will make it a lot easier for non-CFD experts to conduct wind studies. Thanks again for joining us, and thanks to all our speakers. Still to come, we have client presentations and workshops in 4 tracks: concrete, steel, and timber design, as well as facade engineering. Enjoy the rest of the sessions. Thanks again.